Hello guys, I'm going to make some of review problems for the exam 3. You know, in Pearson you have an option to print your homework assignment and to do it on paper, not only on the screen. Find the exact value of cosine of 15 degrees. On the exam it will be written which formula to use for the half angle or for sum or difference identity. In such an example you can use both and you will get different answers depending on the formula. For example, we can use sum or difference and identity will be the sum and difference identity, because 15 degrees can be represented as 45 degrees minus 30 degrees. And then we use the formula for cosine of a sum. Cosine times cosine, cosine 45 times cosine 30, plus, we have a difference here, we have plus, sine of 45, sine of 30. Cosine of 45 as well as sine is square root of 2 over 2. Cosine of 30 is square root of 3 over 2, plus sine of 45 square root of 2 over 2, sine of 30 1/2. So we have the same denominator 4 for both fractions. Here in the numerator we have square root of 2 times square root of 3 is square root of 6. And in the second term plus square root of 2. So we could use half angle identity for the same problem. Then it is a first quadrant, so we take square root with plus square root of, in the identity for cosine we have plus 1 plus cosine of a double angle. So if alpha is 15, then 2 alpha will be 30. Cosine of 30 degrees is square root of 3 over 2 divided by 2. And if you write this fraction with the same denominator, you will get 4 in denominator. Square root of 4 is 2. And in the numerator, if you represent 1 as 2 over 2, you will get 2 plus square root of 3. So in the numerator, square root of 2 plus square root of 3. So find the exact value of cosine of negative 105 degrees. Let us use again cosine of sum identity. First, recall that cosine is an even function, so cosine of negative 105 will be equal to cosine of 105 degrees. Then 105 can be represented as a sum like 60 plus 45. 60 degrees plus 45 degrees. Cosine of a sum is a product of cosines. Cosine of 60 times cosine of 45 minus sine of 60 sine of 45. Cosine of 60 square root of 3 over 2, cosine of 45 square root of 2 over 2 minus sine of 60, cosine was 1/2. Sine of 60 square root of 3 over 2 and sine of 45 square root of 2 over 2. So we have the same denominator 4 and numerators are square root of 2 minus square root of 6. I forgot to tell you that in the previous problem, so we got two different answers, but actually it can be shown that they are equal to each other. Okay, let us write the expression as a single function of x. So cosine of 180 degrees plus x. So it is also the problem for cosine of a sum identity. we have cosine of 180 plus x. So cosine of 180 times cosine of x minus sine of 180 sine of x. 180 on the unit circle is here, so cosine, the x-coordinate is -1 and sine is 0. So sine of 180 is 0, the second term is 0. Cosine of 180 is -1, so this is equal to negative cosine of x. Use the sum or different formula to find the value of sine of 15 degrees. So now 15 can be represented as the difference 45 minus 30 degrees. So sine of difference, we have product sine times cosine, and the same difference sine. Sine of 45 times cosine of 30 minus cosine of 45 sine of 30. Sine of 45 square root of 2 over 2 cosine of 30 square root of 3 over 2 minus cosine of 45 square root of 2 over 2 sine of 30 1/2. So the same denominator 4. First term has numerator square root of 6 minus square root of 2. Use sum difference identity to find the value of tangent of 15. Let us keep this problem. So let us take another next one. Tangent of 45 degrees plus z. So tangent of a sum is tangent of the first of 45 plus tangent of a second, tangent of z, divided by 1 minus tangent of 45, tangent of z. So 45 degrees is in the middle of the first quadrant here. This angle had the same x and y coordinate, the same sine and cosine value. So sine over cosine or y over x will always 1. So tangent of 45 is 1. So this is equal 1 plus tangent of z divided by 1 minus tangent of z.